So I received a question to talk more about derivatives, specifically about how to do the quotient rule, which was in one of your homework questions. So the general notation that you'll see for the quotient rule, if you look it up on Google or something like this, f of x is equal to g of x divided by h of x. So we have a division problem. We have some kind of quotient. To take the derivative of a fraction, of a numerator over a denominator, we have our notation f prime of x. This means derivative of the function f with respect to x is going to be equal to g prime of x. That means the derivative of the numerator of this top function times the bottom function times the denominator, the h of x, minus the top function, the numerator g of x, times the derivative of the denominator, all divided by the absolute value of the denominator h of x squared. So this is very complicated, this is very tricky to remember, but we have a nice little shortcut, nice little song that I use still since learning about derivatives about 20 years ago. The approach that I use to do the quotient rule, this has worked for me, like I said, for about 15 years. I use Snow White to do calculus. If anybody's ever seen Snow White, we have these 7 dwarfs. The 7 dwarfs, they're very studious folks, and they're constantly going to work. And they sing a song about going to work. They sing a song, hi-ho, hi-ho. It's off to work we go. And we're going to remember this song for taking derivatives with the quotient rule. So let's write a new function. Let's write our function f of x, and I'm going to say that that's equal to hi divided by ho. Now all we have to remember is Snow White and the 7 dwarfs. Hi is the numerator, the function up top. Ho is the denominator, the function down bottom. And then we can easily take our derivative. Quite literally, I always say this in my head. I remember my function f of x equals hi over ho. And to take my derivative, my f prime of x is going to be equal to ho d hi minus hi d ho, all divided by ho ho. And this is the quotient rule. If we look closely at it, it's repeating the exact same thing we have for the general equation for the quotient rule. It's just a little bit easier for me to remember. We have ho, the denominator, times d hi, which is the derivative of the upper part, the derivative of the numerator, minus hi times the derivative of the denominator, ho, all divided by ho ho, the denominator squared. And sure enough, if we write our general case, f of x is equal to g of x over h of x. I take the derivative, and I have my denominator, h of x, or ho, h of x, ho, times the derivative of the numerator, g prime of x, numerator, hi, derivative of hi, minus hi, the numerator, g of x, or hi, which we see right here, times the derivative of the denominator, d ho, h prime of x, denominator, denominator, all divided by ho ho, the denominator squared. H of x is our denominator, h of x squared. It's just much easier to remember. Ho d hi minus hi d ho divided by ho ho. So let's see an application of this. Let's take the derivative of this function, f of x is equal to x squared divided by 2x. So f prime of x has to be equal to ho d hi. I'm going to take ho is the new denominator, which is 2x, times d hi, the derivative with respect to x of x squared, ho times the derivative of the high, minus high, the numerator, which is x squared, times derivative of the denominator, 2x, all divided by ho, 2x squared. I've just repeated ho d high minus high d ho divided by ho. And I can just expand this out. So let me take my requisite derivatives. F prime of x is equal to 2x times the derivative of x squared, which is going to be 2x by the power rule, minus x squared times the derivative of 2x, which is going to be 2, all divided by ho, which is going to be 4x squared. I can multiply this out a little bit more. F prime of x is going to be 4x squared minus 2x squared, all divided by 4x squared. And I can simplify this even more to find 2x squared divided by 4x squared. And I get my final derivative answer is equal to 1/2.